Alrighty, thank you so much. I always say it's hard to follow a tough act, but no act is tougher than lunch. But I'll do my best. And one thing is we want to make sure that as any speaker, you're leaving this session with a new nugget of information. A little bit about today's talk, we're going to be talking about cloud metadata service and the abuses we're seeing it on the front lines from different threat actors. And we're going to really particularly speak on a particular use case. So quick little, we'll give us some small introductions of ourselves, a little overview of what is the instance metadata service. We're going to actually talk about that across the three major cloud platforms, AWS, GCP, and Azure. But then we're going to really focus on AWS towards the end. We're going to then speak a little bit about the threat landscape. So what is happening that we're seeing that are being abused by threat actors or can be abused by threat actors around the cloud metadata. And then we're going to get into the specific use case where we saw threat actors able to abuse this at a large grand scale and kind of go through the timeline of the attack. And then towards the end, we're going to do a demo of exactly what the threat actor did and utilized in order to perform this attack. And then we're going to be doing this detections, how to detect this in your environment, how to remediate, how to prevent, and then we're going to finally do that same demo to show that the prevention techniques was able to successfully block this specific attack. And we are really, we try to plan ahead. We made sure the demo gods isn't always working in people's favor. So what we did, we had video demos, which we'll be talking through it. As always, this is more of a housekeeping item. The case studies and the examples that we're going to be talking about is really around, just various different attacks and things that we've seen on the front lines that are public knowledge and just from our proactive type engagements. There's not one specific client we're speaking of, just because we want to obfuscate as much to try to keep our clients' confidentiality intact. So a little bit about myself. I'm Nader Zaveri. I'm a senior manager within Mandiant, specifically part of our security transformational services practice. Say that 3 times fast, I dare you. It's a very unique practice though. So within Mandiant, as we know, we have the incident response services, which is our foremost service that we provide. We're the containment remediation arm during an incident. So as investigators, as Brandan and his team are investigating, we're there to help plug the holes that the attackers were able to utilize and also help remediate additional holes and gaps that maybe the attacker may try to pivot. Another facet of what we do here at STS is proactive engagements. So throughout the talk, you're going to hear me talk about things that I've seen from the front lines, as well as organizations that are being proactive. They want to be able to test and assess their cloud environment, so they call us and we perform proactive engagements and assessments across their environment, regardless of the cloud platform.
And my name is Brandan Schondorfer. I am a principal consultant with Mandiant services team focusing on incident response and digital forensics. My focus is similar to Nader in that, when an incident occurs, we're those individuals that are in the front lines responding to breaches, as well as performing some of the behind-the-scenes activities where it comes to actually what occurred and recreating and following the breadcrumbs to the overall incidents. I have a degree in digital forensics, as well as I've responded to both many ransomware and nation-state threat actors as well over the years. I as well provide, with my free time as well, or the lack thereof, other industry advisory to other organizations. And I am an instructor for our incident response and other related course content. I also manage a team of individuals in our San Francisco office, but I recently moved to Arizona, and it's been an interesting transition between just the general teams at Mandiant.
Awesome. So first, before we kind of break into exactly what happened, we want to kind of level set the terminologies when we're talking about instance metadata service. what do we mean? What is instance metadata? What is it related to AWS? But really, this is across cloud platforms. One thing is it provides critical information. So if you have a virtual machine that's in the cloud or EC2 instance, in this case with AWS, it's a setup to be a non-routable link local IP address, 169.254, 169.254. You could do a simple curl command, and it provides critical information for the operating system, IP address, what subnet they're in, what availability zone, some of the key things that a application may need. So sometimes a developer needs this to be able to provide critical information, but also you can supply certain scripts, like startup scripts within the user data, to be able to have the virtual machine run. And one of the things is this is across really cloud platforms, and we're speaking a little bit more deeply on AWS, but Azure has its instance metadata service as well as GCP. Now we know a little bit about what is the instance metadata service. Why do we care? We will be talking a little bit more on AWS Instance Metadata Service version 1 versus version 2. One thing is this is not a vulnerability. It is a misconfiguration. So it's not going to be caught by normal vulnerability scanners. This is a misconfiguration. It is meant to be like this for a certain time. And one thing is, just anecdotally, and I'm glad this just came out about a week and a half ago by Datadog, where they went and scoured their 600 plus organizations, and the specific misconfiguration, which is version 1, and we'll talk a little bit about what happens in version 1 versus version 2. This 93% of EC2 instances had this misconfiguration, and 95% of organizations across their span of 600 plus organizations had at least one or more instances. And this is something that anecdotally I can kind of speak to just from doing hundreds of IRs and proactive assessments. This is a common finding we see across the different AWS environments that we see, is this specific configuration is turned on. It's not turned off by default. It's turned on by default, IMDs v1. And when you run a specific configuration within an EC2, for example, you'll see the HTTP token set to optional. We will talk about what happens when you set it to required and what it stops. One thing is, this is not something new, right? The IMDs v1 abuse that happened is not something new. This happened at Capital One breach, the very infamous Capital One breach that we are all well aware of. The threat actor utilized this attack in 2019, and by November-December time period, AWS in 2019 was able to create the version 2. It's not turned off by default, so majority of organizations that we've seen still have this misconfiguration. One thing, as I mentioned, is as this instance metadata service is being utilized, there are things like a user data script. You can load as you load a EC2 instance, similar to, if you recall, in your Windows days, right? There's a logon script that can allow for mapping of drives, and a lot of times those user data scripts, and what we've seen just through our various different IRs, they have clear text passwords. If you have a password and they're utilizing PowerShell or Bash, you can see the password in clear text. So if a threat actor has the ability to query this from the outside, or have the ability to get access to the EC2 instance, if they were to query the user data scripts within the instance metadata service, they'll be able to obtain those passwords. And once this problem of this misconfiguration gets really exacerbated, once you see a vulnerable application that has a SSRF, a vulnerability, an SSR vulnerability, that will then take this misconfiguration and really expand it out even further because of the ability to query it from the outside. And Brandon will kind of talk about a little bit about what exactly we saw and how a threat actor was able to utilize this and be able to query and things from the outside without it being inside the actual instance. Because remember, this is a link local IP address. It's non-routable. Only way that this can happen from the outside is through an SSRF vulnerability. And one thing we really wanted to discuss, and one of the reasons why once this came up, we went through the whole process, and we realized that this may be, and we talked internally through threat intel. I talked to various contacts in other cloud security communities, and this may have been the first time we've seen a threat actor take a misconfiguration, specific misconfiguration, across an entire set of IP CIDR ranges against a cloud provider. So they had a misconfiguration, they knew they had a SSRF vulnerable application, and they essentially sprayed and prayed across a set. I think we have over 2,100 IPs. They were spraying this specific threat actor. Brandon will talk a little bit more about what exactly we saw from a forensic standpoint and what exactly happened.
Great, thanks, Nader. Yeah, definitely this is pretty unique in general across the board that we've seen a threat actor target really all IP ranges related to a hosted infrastructure, in particular to AWS. We've seen the threat actor as well scan other resources for other similar misconfigurations and other cloud-hosted services. We'll definitely talk through some of those, but in particularly, definitely cloud-hosted services are a rather attractive target for similar threat actors just in general because of the proliferation of cloud-hosted resources and the available information, including things like configurations and other topology, and most predominantly in this particular case, credential information that was leveraged to further the attack that they were able to carry out. We will cover kind of a demo of what we saw in this particular case, but related to the actual infrastructure, this was especially challenging because the number and amount of log data that was actually recorded was rather minimal in comparison to other like locally hosted platforms or things that in general would have more verbose logging out of the box. The other thing in particular we saw of UNC 2903 was obviously exploitation and targeting of other services and other applications that were hosted in the AWS IP address range space, and then further abuse of IMDs v1. And as Nader had mentioned, not only is this a misconfiguration, but the fact that it's on hosted infrastructure in the cloud makes it easy to identify external applications that if a CVE is released, to obtain information to further an attack, or things like remote code execution to obtain temporary access keys and credentials. The other thing as well is, in this particular case, it was very limited to a single system that had been inadvertently open to the internet. However, similarly with the roles that are assigned to VMs, sometimes there's just configurations which allow a role not only on one VM, but multiple VMs. So narrowing down where credential exposure might have occurred gets definitely more complicated, as there are other access roles and keys that share the same permissions that might have access to a particular S3 bucket or some other resource that has or is used to store data. And as I had said, activity expands over all industry verticals for cloud hosting platforms. So this isn't limited to just AWS, but there are existing and similar threats in AWS, GCP, as well as Azure that host similar metadata services.
Yeah, and one thing to kind of note, and I think Brandon had mentioned this, we aren't specifically talking about the CVE, the vulnerability that the threat actor utilized, which they did utilize a vulnerability, an SSRF vulnerability within an application, because we're trying to nip it at the bud where if we patch this one application, a new SSRF will come about. We're looking at specifically the misconfiguration of this metadata service and focusing on that because that is at the root of the problem, where if you'll see during our talk when we were going through the remediation methods, you will see us be able to remediate and turn on the IMDs version 2 and be able to stop this type of attack. So this is why our talk is really focusing mainly on the misconfiguration, the setting, as opposed to just a CVE, because this CVE is here today, another one's going to be here tomorrow, and really trying to focus on how to remediate this head on. And as we mentioned, we're going to focus a little bit on AWS, but across different platforms, like Azure has its metadata service. Azure does it very well, specifically because they require the metadata service tag to be added during the packet, but also anytime they have something like an X forwarded for message, they will automatically reject it. The X forwarded for is really key because it will talk about if something is coming from a relay server or a proxy, it will then automatically block it. And it requires an OAuth token to be had in order for you to query the metadata service. But even then, there's some great articles around how you could use Azure managed identities as a way to abuse and proliferate. And there's some great articles from Carl and Marius around different ways of using Azure managed identities and being able to abuse Azure utilizing the metadata service. With Google Cloud, it's similar, as I mentioned. They require a header. A metadata flavor has to have, the header must have the metadata flavor Google, as well as they block X forwarded for messages. So they do that same thing, but this wasn't always the case. The older versions, version 0.1 or V1 beta 1, back maybe a few years back, that allowed and that didn't require that header to be there, which then allowed for, let's say, a similar type of attack, an SSRF type attack to occur, but that is no longer supported. So now it's only a version 1, which then blocks the capability. But even then, as I mentioned, there's ways you could query the metadata service once you do have access to the EC2 instance, to be able to get all the metadata, sometimes add SSH keys at the project level, which some of the articles that talked about this were Matiga recently did this, as well as ANCAT, which is a great website for a lot of cloud pen testing, talks about this as well, how you could query the metadata, get your SSH keys, and put it at the project level and not just at the instance level. And the whole point is we want to show that this cloud metadata abuse can occur across cloud platforms, but this specific case, because of the header not requiring the X forwarded for, allows for the proliferation and to make this as large of a scope as possible.
One thing that was notable as well is how long similar metadata services existed, and I think Nader had given an example of even GCP has some available configurations for using metadata since back in 2017, and then some other people that have attempted to abuse that, even if it's in a testing form. Similarly, the other example Nader had given was the Capital One event, where there obviously was the usage of similar metadata services and abuse of related credentialing. And then more recently, in February of 2021, we had basically a database management software, CVE, that was originally announced, and then for this particular version of the database software called Adminer, it allowed basically the usage of a server-side request forgery, which then the threat actor kind of chained that for usage, and with the understanding of the metadata services existing in AWS Cloud, they were able to obtain a proof of concept code, which was subsequently released, and then the proof of concept, essentially, we have circumstantial evidence that that proof of concept was utilized to then perform this particular attack. That also was available pretty quickly using various open source and Google searches. It's easy enough to find the CVE and then abuse that across the platform. Within 3 months, we saw basically the usage of this particular CVE along with the proof of concept, which will give you a demo, to automate the identification of vulnerable versions of the admin software on the web platform itself. We saw then subsequently the retrieval of the EC2 instance roles, and then the acquisition of the credential to subsequently use in the attack. From there, they utilized the key credential to log into the AWS command line, conduct reconnaissance of the available data in the S3 bucket that the keys had credentials with, and then perform data theft from the available bucket. The thing that's interesting with that as well is once they obtain the keys and the temporary access credentials, that was when some of the alerting went off, which we'll talk to that in a later slide. But in general, the threat actor in this particular case, not only from the initial release of the proof of concept, but even on the date June, we saw the reconnaissance and then data theft, I believe, within 3 hours of the attack itself. So moving rather quickly.
Yeah, so that's a great point where as soon as they were able to obtain credentials, we saw them right in the environment fairly quickly. And another thing I think to mention, as I mentioned a few times, is this is one CVE that was created. The POC was out there, and that's one thing is it's only so much you could be ahead of on vulnerabilities. I have just a little story where a vulnerability was disclosed October 21st. 7 days later, a POC, a proof of concept, came out on the internet, the 27th. By the 28th, that client that we were doing the IR was breached with that same proof of concept. So it's only so much you can be ahead of these vulnerabilities. This is why we really want to focus on the configurations and settings. And one thing I will say, just from a suggestion, when you are doing your vulnerability scanning, you're seeing just a lot of vulnerabilities that come out based off of whatever Nessus scan or other vulnerability scanning software that you're utilizing. One thing to help prioritize it is if a POC is out there, if a proof of concept has been published, that is something you want to definitely get ahead of and try to patch that right away. And you'll notice as well, CISA doesn't always publish bulletins for every vulnerability out there, but once you see a proof of concept that's out there that is something that's internet accessible, you'll see a bulletin come out right away for that. So just trying to help with, staying on top of your threat and vulnerability management is trying to figure out if those are out there that is any script kiddie who can get on a GitHub and utilize, which we have some circumstantial evidence that the POC that was utilized was the same one that was found.
In this particular case, the way that the demo is going to work is very similar to what we believe the threat actor had performed. Prior to this stage, leading up to what we're going to show in the demo, basically we saw the threat actor scan the web application and then subsequently perform the attack. The fact that the infrastructure was hosted in AWS obviously is one of the key factors in this particular case. But in general, across our client base, once we were able to obtain some of the IP addresses that we identified as related to the threat actor activity, we saw that there were other similar characteristics where our threat intelligence team was able to match on, I believe, on 2,100 IP addresses that had scanned for similar vulnerabilities around the same time. So kind of an interesting tidbit of information there. But the way that the attack works is somewhat counterintuitive from an investigative standpoint, mainly as well because there is not really command and control traffic, but there's a operational relay box, which is essentially the attacker's command and control system. The proof of concept code that was released, what they ended up doing was running that on their local system. And then navigating to the vulnerable adminer page. We'll show you the demo of this in a couple of seconds here, but once they navigated to the adminer page and had the code running on their own box, they typed in the IP address and port, subsequently returned the credentials there shown in step 3. Once they had the credentials themselves, they basically no longer needed the infrastructure hosted on their command and control operational relay box, and they also didn't need access to the front end of the application anymore. They were able to log in, utilize the keys, and then exfiltrate the data from the S3 bucket itself. So pretty quick attack, and I believe in the upcoming slide we have a quick demo.
Yep, so we're going to do the demo with, of course, IMDs v1 enabled. So we're going to walk through this demo with the infrastructure in place that kind of mirrors what we saw the attacker utilize. And you'll see very quickly, as mentioned, with the adminer tool, all they needed was an IP address and a port. And they didn't need a username, didn't need a password, and you'll see access keys and secret access keys to that EC2 instance.
And so what you'll see is the script that we're going to run includes a parameter for the port as well as the URI for the metadata service itself. Subsequently, we change the IP address to our attacker's operational relay box, which is the local system in this particular case, appended by the port. We change the setting for Elasticsearch, hit the login button, and then the credentials are returned to the screen. So a very simple attack in theory, but from an investigative standpoint, it's very challenging to acquire actual relevant data that records the actual happening of this. So in general, I have some commands there to pipe in what the keys and tokens are, and then perform the actual reconnaissance for the buckets, and then download the content. But that's really at a high level what it includes. You'll see on the web server as well the system itself that you type in the IP address, the Amazon Web Services appended by the adminer, again within the vulnerable version, reaching back out as a result of the server-side request forgery back to the command and control operational relay box hosting the script itself. So in general, once you obtain the IAM role, it includes the key and credential information. You can change some of the settings to actually obtain all of the list of available roles, and then subsequently utilize that for the attack itself.
And so now that we know what happened with IMDs v1, as I mentioned, Amazon came out with IMDs version 2 back in November of 2019, and went to the reInvent, and they went live. But as we just saw from that data, as well as just anecdotally, we see this in almost every environment. So what is different with IMDs version 2 than version 1? Version 2, it's now a session-based protocol, a session-based model, where you have, instead of starting with the GET request, you put a PUT request to obtain a token, and then from that token, you could then start querying the metadata service. If it was coming from a relay box, it would fail because it requires that X forwarded 4 to not be there. If it sees a packet with an X forwarded 4 there, it will block it. And it does require the attribute and the header to have metadata service. They've also added CloudWatch metrics. So if the metadata service is being utilized and version 1, you'll be able to get that. And I'll talk a little bit about the different detection techniques internally of how you can be able to see it, as well as some open source tools to just verify. If you have an organization that runs AWS, one thing to do today or Monday is to check out your AWS EC2 instances. Some of the native services that you could utilize, there's a native services as AWS Security Hub. They have its own detection now that allows you to see if a EC2 instance has a IMDs version 1 enabled. There's specific CloudWatch metrics, as I mentioned. If IMDs version 1 is enabled on an EC2 instance or is being utilized, they'll be able to do that, as well as a config rule. You can utilize a config rule to be able to do remediation. There's open source tools out there. So I'm a big proponent, especially of the security community, to not only utilize native services, but if you need to utilize open source tools, get great open source tools and reputable open source tools like Prowler or Metabadger, which is a tool just dedicated to be able to remediate and take away and discover and remediate IMDs version 1 vulnerable systems there. And of course, there's Cloud Mapper made by a great kind of cloud security guys and some of our cloud security personnel. And there's always ways to discover just purely through the AWS command line interface. You could utilize it and be able to query, and when you're going through the query of a describe EC2 describe instance, you'll be able to see where we're going to talk about in a little bit was the HTTP-token being set to optional in the beginning, and once we set it to required, you will see the difference in the what comes out. So a little bit about the detection.
So in general, this particular type of attack is pretty challenging to investigate, although as quick as we were able to demonstrate the actual event, it really doesn't have too many logs that were generated. In a couple of events that we've had that were similar, the main thing that we had to kind of key us on as to whether or not exfiltration had occurred of either the credential itself or the bucket itself are related to guard duty, which in some of our testing we found that either the data has already been taken and there's been an alert, or the key itself, the credential from the role basically has been taken. You'll see that there's really two primary alerts for the credential theft itself. One is the instance credential exfiltration, and then instance credential exfiltration outside, either inside or outside of the AWS environment itself. In particularly, it is incredibly challenging to figure out, in some cases, what the alert means, because the metadata services themselves, at least for AWS, is rather sparse and limited. The reason being, I guess in general, is some logging which shows the usage subsequently of the credential maliciously. But in general, the instance metadata service, because of the way that it uses the link local address, there's not like an HTTP log which records illegitimate or even legitimate requests for the tokens themselves. So because of the server-side request forgery and the system querying the metadata service as if it were a local system, there's limited data that's recorded by the actual metadata service, and I don't believe there's anything that really can increase the verbosity of the logging for the metadata piece itself. The other thing that was challenging was the available VPC flow logs. What we had seen was once the threat actor performed this particular attack, we saw kind of an anomaly in the network traffic where we saw the web request, which looked failed, and I'll explain that in a couple of seconds, but from the failure in the web log itself, we saw traffic outbound from the EC2 instance, which was an anomaly because we're like, why is the EC2 instance reaching out to the internet? So in the logs, we ended up seeing 302 redirect and a 403 error message that, as an investigator, kind of threw us off as to why the application was erroring out, because you would assume that would be a failure. But the failures were relevant, matching that up from a timeline perspective with the VPC flow logs, because we were able to see the outbound traffic, which we were able to make some conclusions based on the web request itself, which included an unknown IP address and a port number, plus the VPC flow logs outbound, that there was something else going on from a vulnerability standpoint. And then subsequently, the timing aligned very well with the object level access logs and data events, where we could see the copying of the data using the AWS command line in subsequent actions.
And I think one thing to mention, I think Brandan had talked about this, is there's a delay, right, that happens from the time of exfiltration before the alert. We're using demo-sized, time of small type of data exfiltration, but there is just a delay in general, and also it's an alert, right? It's not a prevention. And actually, just came out yesterday is if you utilize AWS Detective it now can group your guard duty alerts and your VPC flow logs. That just came out last night. I think I just tweeted about that. I'm not just trying to drop my Twitter. I was for real. It did just come out last night where you can now group your guard duty alerts with your VPC flow logs and stack them up for easier triaging. And that just came out with Detective last night. So there's strides that are happening from the AWS standpoint. But one thing is, how can we? Okay, we've discovered it. We've detected it. How can we remediate it? There's a few ways to remediate. All right, there is, do you even need this instance metadata service? There's many times, and a majority of the time, you don't need the instance metadata service unless your application or your team needs it for a specific reason, from getting the IP address, the availability zone, the subnet. You can disable that entire instance metadata service at once. Just it's as you're going through the EC2 metadata option, you put in HTTP-endpoint, put false or disabled, and you'll be able to block the ability for even anyone to utilize that if it's needed, right? So you talk to your team, they said, no, we need this because we can do X, Y, and Z. You can then require who can utilize it. You can put it at the IP table where you can say only Bob can query this specific IP address, 169.254, 169.254, and you can block it like that. And you can also just utilize open source tools. If you talk to your team and realize we don't really need this at all, let's just go through the entire litany of lists. There's ways that utilize this from open source tools. Metabadger is another one I talked about already. Open source tool that goes through all your instances, discovers them. If they are, you can remediate them in a single stroke. So now we've remediated it. How can we prevent it from happening again, right? So we want to make sure after we're done remediating, I don't want to talk about IMD as V1 again, because it's just not something I, as a information security officer, want to consistently worry about. You can do it in many different ways. There's SCPs, service control policies, where you can say only those that have EC2 instances that are version 2 can query. Can be in our environment. So you can only limit your environment to EC2 version, IMD as version 2. There is, so if you were to create a EC2 instance with version 1 and not putting the disabled function, it will not allow you to create the EC2 instance. There's infrastructure as code methodologies, right? If you are not doing it through the console, and the true method we want to do is always push infrastructure as code. We don't want to have a lot of people having their hands in the cookie jar in terms of being able to make modifications to your environment. You utilize infrastructure as code, CloudFormation, Terraform. There's Terraform techniques and CloudFormation techniques to be able to block it. And then you could utilize in the local IAM policy. If you have one AWS account not using AWS organizations, you don't want to use SCPs, you could utilize it where you can block the ability from users launching any EC2 instance that does not have version 2 required. And some additional prevention techniques. So let's say you have to have it. We have to have Bob, who has the ability to query it. There's ways that you want to still harden it, right? As I mentioned, user data scripts, that launching script that happens initially when an EC2 instance is created and launched. There's a user data script. You want to make sure you're going through those scripts and ensuring there's no clear text passwords. There's open source tools that can catch it, like Scout Suite, that can catch that for you. There's, you want to limit the number of HTTP hops. So it's not going through a relay server. You can limit it to 1. There's you can go from 1 all the way to 64, but you can say I only want it to go through 1 hop, so it's not going through, let's say, a relay server that may have caused this to happen. And you can limit who can utilize it, as I mentioned, just through an IAM policy, and then also who can modify the IMD as version 1 and 2. You could do that at the IAM level as well. So demo number 2, we're going to see what we turned it on. We did some magic in the back. We turned it on. Now version 2 is enabled. And Brandan's going to walk through what happens after that.
So very similarly, running the command to include the port number as well as the metadata service itself on the operational relay box. Once that runs, it's operational on the actual system itself. Change the setting to Elasticsearch, and then change the source and port IP address, and basically it errors out instead of returns the credentials to the screen. That's because the put request, there's two pieces. Obviously, once IMDs v2 has to be enabled, one is the put request to basically authorize the request, and then an additional request to obtain the credentials themselves. And in general, this is kind of the mitigation, at least if there are internet-facing systems or similar infrastructure set up in AWS, at least one way to remediate the overall event.
Awesome. So as you can see, it's unauthorized, 401 unauthorized attempt. As Brandan mentioned, it requires a put request to get the session token to then be able to query. Because this doesn't have that, it's a relay box. It doesn't truly have access internally to the EC2 instance. We aren't able to get that. So really action item for everyone at the end of this session is go to your teams. If you have an AWS instance, if you have AWS in your environment, ensure and say, do we have any IMDs version 1 enabled? I don't know, then here's a few things, and actually it goes straight into our next slide. We actually put out a blog a few months back with the help of some others within our team and Threat Intel, where we walk through the entire process of the threat actor, but also the specific mitigations. It's about 10 plus pages of detection techniques, prevention, mitigations, and remediation techniques. So go to your teams, say if we have IMDs v1 enabled, I want to know how many do we have, and do we need it or not, and be able to remediate that as soon as possible. And that concludes our session. If there's any questions.
I guess one more closing thought is, as well, depending on the actual vulnerability scanner or anything like that, it's obviously not a vulnerability, it's a misconfiguration, which is one of the key pieces I think we're trying to get the teams to take away with them, in that there might be something that is low priority or low risk if it's an internal system, or might not necessarily have internet accessibility, but that paired with the fact that there was a vulnerability on this server makes this a little bit more of a challenge to not only respond to, but to figure out how to remediate and make the system hardened and more secure. Because the attack itself is rather simple and was carried out rather rapidly, and unfortunately there's a couple clients that ended up in a similar boat where it was too late when there was an identification after the exfiltration had occurred.
Yep, that's a great point. A vulnerability scanner will not catch this. This is where you need to expand your vulnerability scanners to have something like an attack surface management, where it can catch things that are major misconfigurations that they see from the outside, to be able to catch something like an ASM that could be able to catch these misconfigurations and be able to notify the team that you do have EC2 instances that have version 1 enabled. Great point. Robert?
All right, thank you guys. That was great. If you guys have any questions for Brandan or Nader, they will be outside those doors to my right, your left, in about 5 minutes, and they'll be there for about 10 or 15 minutes if you want to chat. We'll be back here at 2:45, I believe, so in about 15 minutes. Give it up again for Brandan and Nader.
Thank you.